All right, just a quick talk about alkene physical properties. So, put this question up here: would either of these molecules be polar? And I think like what the rule would be is if there is a small enough difference in electronegativity of the atoms that it's technically considered a nonpolar bond. So like this has all CHs; those are all nonpolar bonds, and we'd say this has all CHs too, and CCs, which we would also consider nonpolar. So we could say that both of these technically have van der Waals forces, but it turns out that alkenes have a little bit more polarity compared to alkanes. So why is that? Well, when we consider the carbons of the alkene, their hybridization's a little bit different, right? That carbon is hybridized what? Answer for yourself. It's sp2. So it's sp2 hybridized. So what does that mean compared to these, which are sp3? If you're more parts p or fewer parts s, that carbon is 25%, has 25% s character in each of those orbitals. And the carbon there has 33% s character because it's one part s. So 33% s in each of those orbitals. And it turns out that the more s character you are, the more s character that you have, the closer that you hold the electrons to your nucleus. So if we had a carbon that has an sp2 orbital, so this is a carbon sp2, bonded to a carbon that is sp3, that carbon is going to have a longer, less tightly held bond. So this would be the carbon of the alkene. This is the carbon of the alkane. So this CH3 is actually not holding those electrons as closely as this carbon here. So it turns out that both of these carbons are a little bit more polar. So sp2 carbons are slightly more polar. So because of that, they actually draw electron density a little bit to themselves, and these are a little bit polar bonds to some degree. That doesn't have a huge impact on the physical properties. This is actually a larger molecule by 2 atomic mass units. So if it had no impact and this wasn't polar, because if we add those dipole moments together, we would technically have a dipole moment going that direction of that molecule. This one has no dipole moment. And this molecule here has a boiling point of -1 degree Celsius, butane. It turns out that cis-butene, this one over here, has a boiling point of, I think, 4 degrees Celsius. So somehow the heightened S character allows for a bond to be a little bit polarized, creating a small dipole moment. So for alkenes, we can actually say that they have van der Waals forces and dipole-dipole. I'm going to write here slight, because it is a very slight dipole-dipole, but it does actually have an impact on the physical properties. So we should give it its due. That's really the only difference compared to alkenes. They have slightly different physical properties because of that greater S character. So hopefully that made sense. Let me know if there are any questions.